All right, all things having to do with doing math with fractions, multiplying them, adding them, subtracting them, dividing them, and also doing the same operations with decimals. We start with multiplying fractions because it's the easiest. So when you multiply two fractions, this is one of those times in math when the thing that you want to happen just is the thing that happens. So you literally just multiply the numerators and you multiply the denominators, like that. So I don't want you to think of that as a rule that you have to memorize, just sort of internalize it as just a nice way the math works out nicely, that you just multiply like you think you would. And then any rule we have for negative and positive integers, like putting those together, is going to apply here as well. So let's do an example. And there's a couple kind of competing philosophies of how to do this, even though you're doing the same thing no matter which method you use. So I'm going to try to do it a couple different ways, and then I guess kind of leave it up to you. So what we're going to do is we have a negative times a positive, which means our answer is going to be negative. We're going to just multiply the 60 times the 25 and the 75 times the 4, like that. And then I would rather here, we go on work smart, not hard. So rather than find the prime factorization of 60 and find the prime factorization of 25 and do it with all those numbers, let's actually just look for common factors. Because I think in a problem like this, it's pretty obvious and you can really get this done in one step. So we're really never even going to do what 60 times 25 or 75 times 4. Okay? So in particular, notice that 25 and 75 have a common factor of 25, right? Everything's a multiple of itself. So before we do anything else, we can take a 25 out of the numerator and the denominator, and then notice that also this 60 has a multiple of 4. Or 60 is a multiple of 4. So 60 and 4 have a common factor of 4. So I am going to factor them like that, kind of strategically. Right, so if I call 64 times 15 and I call 75 3 times 25, then you can see all the stuff that just goes away right away. And this is what I mean. We don't really ever have to multiply those numbers together. Okay, so get rid of the 25 and get rid of the 4. We're left with just a negative 15 over 3, and then we can even take it one step further. Right, because negative 15 over 3 is just negative 5. Okay, so there's a more general way of doing that you've probably seen before, where you do the little slash thing, where you actually simplify the numerators and the denominators before you do any multiplication at all, and that's what I'll show you now. Dividing fractions, maybe you remember, we multiply by the reciprocal. So we take the fraction we're dividing by. You remember that dividing is defined as to be the same thing as multiplying by the reciprocal. So you're never really dividing any numbers here. You're just remembering to flip the second fraction. It's important that you flip the second one. Okay, so you flip the divisor over and then you multiply. Okay, so just however you have to remember that, multiply by the reciprocal. So take 44 over 63 and then multiply it by 21 over 88. And here's where I'm going to show you the technique where you simplify before you do any multiplication at all. So let me just copy it over here. This is not really the way your book does it yet, but this is the way I've always shown to do it. So you notice before you do any multiplication that 44 and 88 have a common factor of 44. So if you go ahead and just divide both of those by 44 now, 88 divided by 44 is 2. That's all you're left over with. Same thing. 21 and 63 have a common factor because 63 is 3 times 21. So you can just divide this by 21 as long as you also divide this by 21. And then look at all you're left over with. The only thing you have now is just 1/3 times 1/2. Okay, so it's like we did a multiplication problem, but we never really had to do any multiplication because, well, a little bit, but we simplified everything first. So when it's feasible, I think that's the way to do it. Okay, so we simplified now and we just got 1/3 times 1/2, which is 1/6. Okay, so dividing two fractions is not any harder than multiplying. It's the same exact thing. You just have to remember what to do. Moving right along, I'm just going to kind of crank through this and do one example of each. There's plenty of examples on the homework and in the book. Okay, adding and subtracting fractions with the same denominator. So this is nice. If the denominator is already the same, you just add or subtract the numerators. So there's plenty of ways to visualize this. You know, you have a pizza, it's chopped up into sixths. 4 sixths plus 1 sixth is just 5 sixths. All right, so the denominator, remember the common denominator is what this is called. That stays the same. That does not get added. That doesn't change at all. You just combine the numerators. So either add them or in this case actually subtract them, but you know that it works the same either way. So it's that simple. If I give you 17 tenths minus 1 tenth, you just subtract the numerators and you get 16 tenths. That's probably too easy. And then always, even if it doesn't say, you always want to simplify your fractions. I'll make sure it does say on the exam. But you know that 16 tenths is 8 fifths. Okay, so you would not get all the points if you left it at 16 tenths. All right, so if they don't have the same denominator, you remember this. It's tricky. You have to force them to. There's no other way around it. There's no way to add or subtract two fractions that don't have a common denominator. So you have to get them to. But that's why we talked about things like least common multiples. And the least common denominator is just the least common multiple of the denominators. So you need to force those two fractions to have that denominator, whatever that least common denominator is. For example, negative 2 fifths minus 2 thirds. So we got a couple things going on here because we have to find a common denominator, and then we're also, okay, so we're at a negative number and then we're moving backwards, right? We're moving away from 0 on the number line. So you might want to picture like we're here in negative 2 fifths and then we're going back even farther, another 2 thirds. So the answer is going to be even more negative. So this is one of those ones where we're going to take the absolute values. We're essentially going to take 2 fifths plus 2 thirds. And then we're going to just stick a negative sign onto our answer, right? So we're actually going to add the absolute values. Draw a little number line if that throws you off so you can see what's happening. It's negative and it's moving even more negative. One thing that happens, so 5 and 3 are both prime numbers. More generally, they're called relatively prime. They don't have any common factors. In this case, they don't have any factors at all because they're both prime, right? That's what prime means. So to find their least common multiple, all you have to do is multiply them together. That should kind of make sense. I mean, think about the multiples of 5. They're 5, 10, 15. Wait, stop, because 15 is a multiple of 3. So it's that simple. So if you notice the two numbers either are already prime or don't have any factors in common whatsoever, it's quick to find the LCD. You just multiply them together. Okay, so the least common denominator is 15. You have to make both the fractions have a denominator of 15. So you're going to multiply the first one by 3 thirds and the second one by 5 fifths. So you're going to get what? 6 fifteenths minus 10 fifteenths. Sorry, negative 6 fifteenths. And now here's where you're going to take the absolute values. So you're going to take 6 fifteenths plus 10 fifteenths, which is 16 fifteenths. And then you're just going to say, well, I know that the answer is negative, though, so I'm just going to attach a negative sign to the answer. Maybe you can do that in your head. That would be fine. When I say, like, show your work on this stuff, the showing your work is the finding the common denominator. Going from here to here, yeah, here to here is fine. There's no real work to show. You can explain yourself if you want. Okay, one more because these are not the easiest thing. 5 14ths minus 5 6. So the funny thing here is we don't really know right away whether or not like 5 14ths is bigger than 5 6 in absolute value. Well, if you think about it for a second, you probably figure out that it's not. But once we get that common denominator, then we will know whether our answer is going to be positive or negative. Okay, so do this the old-fashioned way. Do the prime factorization. 6 is 2 times 3, and 14 is 2 times 7. And then remember, from those prime factorizations, okay, we have a 2 in common. So our LCD needs a 2, and then whatever we have left over, it needs a 7 and a 3. So it's 2 times 7 times 3, which is 42. And you can always just think, okay, is 42 a multiple of 14? Yes. Is it a multiple of 6? Yes. So it works. Okay, so multiply the first fraction by what? 3/3, and the second fraction by 7/7. And you're going to get 15 40-seconds minus 35 40-seconds. And now, the other thing that is helpful when you get a common denominator like that is that now you know which one's bigger. The second one's bigger, right? So the negative one, and by bigger, I mean bigger in absolute value, farther away from 0. So since the negative one has more absolute value, your answer is going to be negative. So when you really do this, I mean, you probably just jumped ahead and got to the answer without really thinking about how you were doing it, and that's fine. You're really doing in your head 35 minus 15 is 20, but I know it's negative, so it's just negative 20 over 42. Right, it's like when we do 15 40-seconds minus 35 40-seconds, we go past 0 on the number line and land at 20 40-seconds, negative 20 40-seconds. And then once again, you can see it's very easy to see if both numbers are even, that they obviously have a common factor of 10, or I'm sorry, of 2. So divide them both by 2 and you get 10 over 21. And that's it, right? No more common factors. So the answer is negative 10 over 21. So that's, expect to see something like a lot like that on the exam. All right, so when we're adding and subtracting decimals, this is where we just kind of have to get in there and do, I guess, what I'm going to call long addition and long subtraction. There's really no way around it. So you've seen this process before, but I'll do it just to remind you how it works. Negative 13.2 plus 7.32. So picture a number line. Again, we're starting at negative 13.2 and we're going to that way 7.32. Yes, I'm backwards from you. So we're still going to end up being negative because 13.2 has more absolute value than 7.32. So what we're going to do practically is do 13.2 minus 7.32 and then just jump into the end and remember that our answer actually has to be negative, not positive. All right, so let's do it. So we're going to do 13.2 minus 7.32. All right, first big principle we have to remember here is to line up the decimal places. All right, so you line up the decimal places. You obviously put the numbers subtracting down here. And the second big principle to remember is that we have to have the same amount of digits. So if we don't already have the same amount of digits after the decimal place, we just make it so by filling in zeros. Okay, so here we go. So the third big thing to remember is the concept of borrowing. We can't do 0 minus 2, so we have to do 10 minus 2. And in that process, we borrow 1 from here. So the 2 goes down to a 1. 10 minus 2 is 8. All right, and then just repeat. We can't do 1 minus 3, so we have to borrow something from over here. So this goes down to a 2, and we do 11 minus 3. 11 minus 3 is also 8. All right, decimal places is in the same place in the solution. Can't do 2 minus 7, but I guess my trick here is that we can do 12 minus 7. So rather than borrow something from here and make it be 0, you can just say, wait, I have a 12 here minus a 7, and 12 minus 7 is 5. It's going to be exactly the same. Okay, so that's it. But remember, the answer had to be negative because the negative number had the bigger absolute value. So really the solution is negative 5.88. Again, easy to check with a calculator, and I would encourage you to, just to build your confidence. but of course, that won't help you on the exam. Okay, so that's just a process, just another thing to be good at. All right, one more. So this one's nice because they're all positive, but it's a little less nice because there's 3 of them. So that's okay. Here we go. We can do it all at once. So we have 6.19 plus 2.7. So stack them up, line up the decimals, plus 4.069. Fill in zeros where we need, so that's 6.190 plus 2.700 plus 4.069. All right, and now you just go down, and now instead of borrowing, it's called carrying, right? So 0 plus 0 plus 9 is 9. 9 plus 0 plus 6 is 15. And we have another little 1 that goes up here. 1 plus 1 plus 7 is 9. Decimal place lines up. 6 plus 2 plus 4 is actually 12, and we don't need to carry anything because that's the last thing we're doing. I don't know what happened, but there you go. 12.959. So that's it. That's what I would need to see on your test. Just I would need to see that you did that process. Multiplying decimals, kind of the same deal. It's just another one of those processes like we just did. So it's just kind of a grind, and you just have to write it all out and do it. So the first thing you have to remember is that you just kind of ignore the fact that they're decimals and multiply them as if they were just 2 big whole numbers. And then you just count the number of digits after the decimal point in each of your factors. And then put that total amount of digits in your answer. So you sum the numbers of digits to the right of the decimal. That number becomes the number of digits to the right of the decimal in the product. All right, here we go. 4.73 times 5.2. So we're just going to write them down. So once again, stack them up. Now remember, you don't need to line them up. You don't need to line up when you do multiplication because we're basically ignoring the decimal for right now. So when you do this multiplication, you're not even really using the fact that there's a decimal. Usually we put the times sign here, I guess. I said don't use the X anymore, but I am anyways. Okay, so now, so remember this process. 3 times 2 is 6. So first you deal with the 2. So you do everything times 2. So 7 times 2 is 14. So that's a 4. But then you kind of carry the 1 up here and you add it to this next thing. So 4 times 2 is 8, plus 1 is 9. So it's 946. So 473 times 2 is 946. It's true, it is. All right, then you go down to the next digit and you do the 5, except you put a 0 as a placeholder here because we're moving in another digit. Okay, and do the same process. 3 times 5 is 15, so that's a 5, and you carry the 1 up here. So now we have 7 times 5, which is 35, plus 1 is 36. So you put the 6 here, and then you carry the 3 up to this thing. Let's see, let's get rid of that. And you have 4 times 5, which is 20, plus the 3 is 23. All right, and then you add. Remember, this is more of a process than anything else. So now we're adding. 6 plus 0 is 6, 4 plus 5 is 9, 9 plus 6 is 15, carry the 1, 1 plus 3 is 4, the 2 comes down, right? It's like nothing plus 2. So the answer is not 24,596. And I would like to think that if you got to here, and you would look back at the original problem and say, is there any way 4 point something plus 5 point something could be 24,000 something? No, doesn't seem right. Seems more like it should be 20 something, right? Because 4 times 5 is 20. So it is. So that's when you go, okay, I have 1, where am I? So I have 1, 2 digits here and 1 digit here. So I need 1, 2, 3 digits after the decimal place in my answer, and there it is. There is my answer. 24.596. Let me write that out a little later. 24.596. So obviously easy to check with the calculator, but make sure, more importantly, make sure it seems reasonable. Could 4 point something times 5 point something be 24 point something? Totally, because 4 times 5 is 20, so it should be a little more than that, right? It could not be 24,000 something. So this that's, if there's one thing like you always do in math, is just to stop and just make sure your answer makes sense to you. You're smart. You can just reason it out. Obviously, you couldn't have done that process in your head, but you can go back in at the end and say, does my solution actually make sense with what I was originally asked? All right, and finally, dividing decimals. This is our old friend, long division, and there's no other way around it. So what we do with the decimal place is a little different here. This is the thing where we take the divisor and we move the decimal over until we have a whole number. So we never divide by a decimal. We always divide by a whole number. So if I have, like in my divisor, I have three digits after the decimal place, I have to multiply it essentially by 1,000 so that I have no digits after the decimal place. Now, you know that multiplying by 1,000 just means you move the decimal place over. Okay, so, right, you remember this, you loved it. So that's the easiest way to do this, is just to see an example. Don't worry about what a power of 10 is. For now, we're just moving decimal places. All right, here we go. 17.68 times divided by negative 13.6. So right off the bat, we're not really going to use the negative except in our very final answer. So we know that a positive divided by a negative is negative. So we're going to kind of ignore it and then just remember to throw it back in at the end. So we have to do the thing where we move the decimal place on the 13.6 over 1, but I want to show you what happens when we do that. So I can do that. Essentially, when I move a decimal place over by 1, I'm multiplying by 10. And I can multiply the top and the bottom of a fraction by anything I want. So if I multiply the denominator by 10 and I multiply the numerator by 10, I haven't actually changed anything, right? So that's no different than what I'm doing to set up the long division. It's just we have a particular purpose, which again is always to make this a whole number. Okay, so when we do 176.8 divided by 136, remember it goes kind of backwards from that. So the divisor, the 136, comes out front. And then, again, there's no reason to include the negative sign here. We're just going to remember at the very end of the problem that it was a negative to begin with. Okay, so here we go with long division. So remember the moves. First, you take 136 and you say, how many times does 136 go into 176? I think probably one time. Now, the nice thing here is the decimal place is already kind of set up for us. We don't need to do any kind of math or messing with that. That's a very weird looking one. Okay. So now you multiply 136 times 1 is 136. So there's a bunch of different stuff going on in here when you do long division. Now you subtract. 6 minus 6 is 0. 7 minus 3 is 4. And then we bring stuff down. Remember, we bring down the next digit, which is the 8. You don't have to draw a little arrow there. I just wanted to see where the 8 came from. And then you have to think about how many times 136 goes into 408. So the problem with these is now it's like we need a calculator to figure out what to do in the middle of this problem that we aren't using a calculator for. So, well, you just have to think about it. So if you think about 136 going into 408, think about 2 times, that would only be 200 something, so that's not enough. 3 times, you know, I guess let's just try it. So let's try a 3. Right? If 2 doesn't work, I mean, it kind of must be 3 because it's not 4. Okay, so 3 times 136 is okay. 3 times 6 is 18. Now it's like we're doing long multiplication kind of in our head in the middle of it. 3 times 3 is 9, so that's 10. But we carried a 1, so it's 10. And we carry another 1. 3 times 1 plus 1 is 4. So would you look at that? It just turns out perfectly, which means we have a remainder of 0, which means we're done. So the answer is actually 1.3. And not quite, because it was 17.68 divided by negative 13.6. So it's negative 1.3. There you go. All right, one last little story problem before we end here, because I definitely do want to put a couple little story problems on the test. Your online store had a total revenue of $29,409.12 last year. Good for you. what was the average monthly revenue? All right, so don't let the word average throw you off here. That makes it seem more complicated than it is. All you have to think about is, okay, that was our total, 29,000 something was our total for the year. We want to know, on average, what were we making every month? Well, so we need to chop the year up into months. And another way to say chop up is divide. And then we just have to say, okay, well, how many things are we dividing it into? Well, there's 12 months in a year, right? So we're just taking 29,409.12 and we're chopping it into 12, or dividing by 12. And I think I'll do it just so we have some more practice doing this. Okay, so 12 is already a whole number, so we don't have to do any messing around with the decimal place. It's just this is it, right? And here we go. Okay, so 12 goes into 29 2 times because 12 times 2 is 24. So you multiply, then you subtract. 29 minus 24 is 5. Carry down that 4. 12 goes into 54 4 times, right? Because 12 times 4 is 48. 12 times 4 is 48. Again, we're subtracting. 54 minus 48 is 6. You could certainly use like borrowing to figure that out, or maybe just think about it for a second. 54 minus 48 is 6. All right, carry down the next digit with a 0. Wouldn't you know it? 12 goes into 60 exactly 5 times. Sorry, sometimes I lose my cursor. 5 times 12 is 60. So I'm sorry, I didn't carry down the 0. There's the 0 coming down. And we did 12 times 5, so that's 60. So now we have a 0, and now this is one of those kind of weird parts where there's nothing here, but we have to carry down a 9. Or rather, it's a 0, so we put 0. And then we do 12 times 0 again, and now we're down here. So we have a 0. Now we're at the decimal place. And we carry down, in this case, we can carry down the next 2 digits. So we can carry down the 1 and the 2, because if we just carried down the 1, we wouldn't have anything to go into. So 12 goes into 12 exactly 1 time, and then you just have to remember that since we carried down 2 digits, that it's going to go here. It's going to line up with the 12. So we put the 12 into the 12. So it's 0.01. And this should kind of make sense because we had 12 cents total. So it makes sense that there's like 1 cent for each month. Okay, so your average monthly revenue, and I do want to see units again, and units for here is as simple as just putting a dollar sign. It's $2,450.01. I promise the long division ones on the test will be fairly simple and straightforward. You have to know the process, and you have to show me all those steps. And I know it's a pain, but once we get past this, we don't have to do it as much sometimes. Okay, that's all for today. Thank you.